want to talk about the transformations of functions that my video talked about, but this time I want you to just see what's happening with using Desmos. So I'm going to type in sine of x. Remember, x here is not the coordinate, it's not the x coordinate, it's the variable. We've been calling it t, but I'm going to use x because Desmos likes the variable x. And you can see we have this sine wave that we talked about at the very beginning of the circle, of the unit circle, when the angle is 0. The y value is 0 as well. And so when we climb up to pi halves at the top of the unit circle, our y value is 1. We continue going around, we get to halfway around the circle at pi and we're back to 0. We get 3/4 of the way around, which is 3 pi over 2, and we're at minus 1. Finally, we get back to our beginning, we're at 2 pi, and notice that we really are at the beginning again, and so our period here is 2 pi. We go from 0 to 2 pi, and then we repeat. The same thing happens again and again, just goes on and on, however many times we want to go around that unit circle. So now I'm going to put a 2 in front of this. Oh, let's make it a 3. Let's make it 3 times the sine of x. And before I tap x, I want you to think, what am I going to see? You're going to see every y value multiplied by 3. And there we go. Now, when I get to pi halves, I'm at 3 instead of 1. See, in my regular sine wave, I get to 1. In this new sine wave, because I'm multiplying everything by 3, I get all the way up to 3, all the way down to minus 3. My amplitude is the absolute value of this number 3 in front. And I can't write it on here, but I'll just tell you that the amplitude is indeed 3. Let's erase this now, and let's take sine of x, and let's now put sine of 2x. And what I'm doing here is I'm going to, as I type the x, I want you to think, what's going to happen? Well, I'm doubling every x value. And you're going to see that this foreshortens the period of this new wave. And there you go. I'm going to zoom in now, and you'll see that here 2 times 0 is 0, so I still have the same point 0, 0 at the beginning, but now I finish my period. It goes up and down and back up again in pi rather than 2 pi. And so my period is half of what it used to be. Let's zoom out a bit so you can see this whole thing. The blue is the regular sine wave. The purple is the sine of 2x. Let's go back in. Let's erase that now. And now I want to show you what happens when I say add 2 to, so I've got sine of x now, but now I'm going to shift to the right by going x minus 2. So this point here for my regular sine wave is 0, 0. Now it's 2, 0. The black has shifted to the right 2 units because of saying x minus 2. This next one is pretty straightforward, and what I'm going to do is I'm going to take the sine of x, same number, but now I'm going to subtract 4 from it, and you see that now my corresponding point 0, 0 has become now minus, or 0 minus 4. This is minus 3. That's not so wanting to come across that except, but I can do that one. 3 pi over 2. is now at -5. So everything has shifted down 4 units. Finally, let's put this all together, and we're going to see what happens when I take 3 times the sine of 2 times x minus 2 minus 4. And I get a completely different looking graph because of these changes that I've made. I've done all those 4 changes in one fell swoop. With that, that's how you do it.